Study Buddy!
Greeting guys, welcome back to Study Buddies. In this lesson, we will learn about collision, which is part 3 of linear momentum. Let's look at types of collision. There's two types of collision. The first type of collision is head-on collision, commonly known as one-dimension collision. The motion of the object before and after the head-on collision are in the same straight line. The equation of conservation of momentum for head-on collision is m1u1 plus m2u2 equals to m1v1 plus m2v2. The diagram below shows an example of head-on collision. As you can see, both the objects are moving in the same straight line before and after collision. Moving on to second type of collision, which is oblique collision, also known as two-dimension collision. In this collision, the velocity of the objects have x and y components. It means usually after the collision, the direction of the objects will change, causing those objects to have x and y components. The linear momentum in x and y directions are conserved despite the change in direction of the objects. The equation of conservation of momentum in x component is m1x u1x plus m2x u2x equals to m1x v1x plus m2x v2x, while in y component is m1y u1y plus m2y u2y equals to m1y v1y plus m2y v2y. This diagram shows an example of two-dimension collision. As you can see, the direction of both the objects have changed after the collision. Each object has its own x and y components. For a better understanding, let's do a sample question. A 8 kg mass traveling to the right at 20 meters per second strikes a stationary 3 kg mass at a slight angle in such way that after the collision, the 8 kg mass is traveling at 15 meters per second in 20-degree direction. What is the speed and direction of the second mass after the collision? Based on the diagram, we can conclude that this is a two-dimension collision. First, let's list down all the given information at this site. Since both the objects are traveling horizontally before the collision, they don't have a vertical component. They only have x component. However, both the objects has their own x and y components after the collision. In order to solve this question, we have to resolve the speed of the objects into x and y components. Let's resolve the x and y components of object 1 first. Bear in mind, the axis that touches the angle will use cos, while the one that doesn't touch the angle will use sine. So in this case, when you resolve it, you should get 15 cos 20 as your x component and 15 sine 20 as your y component. Apply the same concept to resolve the x and y component of second object. This will give you v2 cos theta as your x component and negative v2 sine theta as your y component. So you guys might be wondering why the y component of second object is negative but the first object is positive. Alright, if you look at the diagrams, the direction of the y component of the second object is towards negative y-axis, which is downwards, while for the first object, it's towards positive y-axis, which is upwards. This explains why we have to include the negative symbol for the y component of the second object. Now, solve the question by solving each component. Let's solve y component first. Apply the formula we have learned just now, which is m1y u1y plus m2y u2y equals to m1y v1y plus m2y v2y. Substitute the values into the equation. Leave your answer in the form of v2 sin theta equals to 13.68 meter per second and label it as equation 1. Remember, since this equation has two different unknowns, we will need two different equations to solve it. Now, let's solve x component. Use the formula m1x u1x plus m2x u2x equals to m1x v1x plus m2x v2x. Substitute the values into the equation. Leave your answer in the form of v2 cos theta equals to 15.75 meter per second and label it as equation 2. Do you guys still remember the basic concept of trigonometry? Yes, for this type of question, you should apply trigonometry knowledge. To solve this, we should divide equation 1 with equation 2. v2 sin theta over v2 cos theta is equals to 13.68 over 15.75. Since both the numerator and denominator have v2, we can cancel it out. Based on trigonometry concept, sin theta over cos theta will give us tangent theta. Therefore, we can write it down as tangent theta equals to 0.869. To find the direction of second object, inverse tangent 0.869 and you will get theta equals to 40.99 degree below positive x-axis. Substitute the value of theta into equation 1 to find the speed of second object. You can either substitute it into equation 1 or equation 2. Both will give you the same answer, which is 20.86 meter per second. And with that, we have completed linear momentum's lesson. Thank you for watching this video, guys. Hope you all understood today's lesson. Don't forget to like, subscribe, and click on the bell icon down there. See y'all in the next lesson. Bye.